All right, welcome back to Ox Tools. I'm Tom. So we're going to install the digital readout scale today and get that on the lathe. But I'm going to do myself a favor right out of the gate here before I start. I got to do a little drilling and tapping into the machine itself, and there's some small screws and little parts and things like that. So I'm going to do myself a little favor, and because I'm thinking ahead a little bit, at least for once, I'm going to clean that chip pan out real carefully so that there's nothing in there. So if I drop a tool or a screw in there, I can see it. Sometimes I've just laid paper in there when I'm too lazy to clean the chip pan out, but it kind of needs cleaning out now anyway. So I'll give it just kind of a cleanup over the machine, and then we'll get started on putting the X scale on this time. And we built the bracket for the the box, and I'll get that painted today and get that mounted permanently, and start routing cables and stuff. Okay, so let's get suited up and let's get cracking. Okay, so here's where the scale's going to go here, like that, and I've already kind of checked the back and forth to see that I got enough total travel. And then, so this is the moving part of the slide here, and this is the stationary part. So I'm just going to shim that up just a teeny bit. This is a little less than a millimeter here, about 30 thousandths, something like that. So we're going to just shim that. And this is just, right now we're just kind of eyeballing it here to get the plan together, right? So I'm not drilling any holes just yet. We're just kind of putting things in place to see how it all looks, right? It makes sense. All right, so here's the reed head, and I've attached it to the provided mounting bracket, and it's just a cast aluminum bracket. It's not too bad. And it's got some little set screws here. It's going to go up against this kind of rough part of this casting, so we'll have to use those set screws to kind of get this thing aligned. So the reed head has to be aligned in all the axes to perform properly. So let's and it's, looking at it here, I got a little mark on that. It's going to be roughly in the center here. The scale's got the scale itself has plenty of travel to accommodate this machine here. This is a 14-inch scale, and this cross slide has 10.5 inches of total travel. So I'm just very lightly clamping this up here just to kind of get a look at it. So that's about how it's going to be. And then the armored cable will come out the back and be routed down and away from the action there. So let's just get that squared away there. And then I put a bag over the end of this. I don't want any chips or this getting crudted up in here, so I just covered that up. Just kind of good practice there. And so the only thing that's a little bit weird here, this lathe has a dovetail on the top of the slide here, and it looks like these two set screws are going to miss that. But I'm not particularly worried about it because this is an accurately machined surface here. It's not a rough casting, so I'm going to mount the scale flat against that. I probably won't use the set screws at all in that situation. Then I'll adjust the I'll adjust the reed head accordingly. So should be okay. We'll check it with an indicator later on. So the next thing I got to look at here is, this reed head sticks out from the carriage a little bit here. So the tailstock comes up into this area too, and if you're not careful, you can ram the tailstock into this reed head, which would be, in the machining world, we call that unfortunate. A reversal of fortune. Anyway, so we need to build a bracket to protect that. And one of the things I've been thinking about too is I've wanted to connect the tailstock to the carriage with a removable pin. That way I can power feed the tailstock when I'm doing big drilling. At least I want to try it anyway. So what I'll probably do is incorporate that feature into this this protected bracket that protects this reed head. So I'm going to sketch that up, and well, actually I'll probably get this mounted first, and then make the protective bracket after this is mounted. It'll just be easier. All that stuff will be in position. So let's get some tools over here, and we'll get this scale mounted first, and then we'll get the reed head mounted second. So let's go for it. Okay, so I got the scale basically where I want it. I'm just going to very lightly clamp this thing in position, just to hold it while I transfer punch it. Let's check that. Yeah, okay, it's good. Down on the shim. So this is just, you know, very light pressure, and you know the scale's up against that, so it's not deflecting the scale. And if I try to move the scale a little bit, it doesn't want to move. So that's what I want. That way I can go in there and just kind of transfer punch these. Now the end mounting bracket is slotted, so what I want to try to do is kind of target the center of that adjustment slot, and that way I get the maximum up or down. I can't think of what I want it now. I'm just going to go in the middle. Okay, and I'm just going to put a little dink right in the, well, let's see, this is, hit in there for a sec. That bracket's, that hole's a little tighter. Let's try that one. Oh yeah, that one goes right in. Okay, I got a little dink in each one, and then let's take this off. Let's see, just for ha-has, I'm going to put a little mark there. Get that out of the way. Oh yeah, I got a nice little mark right there. That was the one I was worried about. I get kind of a little bit of a sissy hit on there. So let's give it a little swat here. I want to make sure I hold this nice and square here. All right. And just for reference, you never want to double hit your center punch, because a lot of times it springs out of the hole and you end up with a second center punch mark. So it's always one hit, take a look, reset if you want it deeper. So it's just good practice. Okay, happy. So I didn't like the screws that the scale came with, they're socket heads, so I'm going to put some slightly different. I'll show you guys that. So this is that's the counter bore that's in there, and that's the screw they give you to put in there, and it's a metric screw. But you can see it's sticking up a little bit. Not that that matters that much. It just doesn't quite seem right to me. So I got some little button heads here. We're going to drop a button head in there, and that's just much sweeter. It's the head of the button head has much larger bearing area. The only disadvantage to the button head is the driver is a little bit small for the size of the screw. It's smaller than the socket head, but you know, we're not reefing on this anyway, and cranking it down. So now that's a metric screw, and this is a 832-inch screw. All right, so let's do a little drilling and tapping there, and get that scale mounted. All right. So actually, I tried using the manual focus here in this particular shot just to try it out. So I made a little drill fixture here just so I drill nice and straight here, and all it is just a block that fits the tap drill. So what I want to do is clamp that on there and get that block clamped on there so that I can drill nice and straight, and I don't have to I can just concentrate on drilling smoothly. So I'm using the transfer punch to line it up in the center punch. And hopefully this clamp will, this clamp is totally going to be in my way here, isn't it? Okay, so it's in the thing. I should have made the thing a little longer. Yeah, it's in there. Okay. See if I can get the drill up in there. That's what I'm worried about now. That's not looking too good. No. Okay. Well, let's just go to plan B. I mean, if I turned it around, that would work, huh? Then I gotta move everything. Okay. All right, well, let me move some junk around here. Okay, I reset everything. I turned it around. So now what I want is I just want some kind of witness mark on the drill so I don't over penetrate there. All right. Let's see what we can do here. A little more. Okay. All right, let's get the block off of there and get a look at Mr. Hole. Yeah, looks like a hole to me. All right, so I think I'll go ahead and tap that right now while I'm there. Okay. Let's go ahead and tap that. And this block, all it's doing is just squaring up my tap so I can get it started nice. I'm going to take it off in a minute. This is not the place to break a tap. Although it feels pretty good. Ooh. Okay. For a second there it felt a little funny, but it's cast iron, so let me spritz that out. So I might grind that tap a little bit so that I can tap a little deeper. Actually, let's try the screw and see how far down it goes. It looks like it might be okay. Okay, so I'll get a little countersink and countersink that edge. Okay, so we got these mounted, so we're going to pull these little shims out. And then what we want to do is we want to make sure that this is straight with the world here. So what we're going to use, we're going to check it with an indicator here and a surface gauge. And we're just going to bend that down like that and get it close. And secure that. And this is a good use of the little pins that pop out of the bottom here, because what we can do with that is we can track along that edge. So I just need to measure a section of this to make sure that this is parallel with the top slide here. So let's adjust that until we get contact. All right, looks pretty good. We'll just slide down here. All right, so it's moving a little bit. So that's 2/1000ths over that distance. All right, so let's see, which way is that going there? It's getting higher. It's getting higher going this way. So I'm going to pick this end up just slightly. Get my Allen wrench here. Oop. Send that thing into the so I'm just going to loosen this, and I'm going to pull this slide up. I'll pull the scale up manually. I'm just going to try pulling it up 1 thou and then locking it down, and then let's track along there again. Oh, it's worse. Makes sense. Did I go the right way? It's going higher. Oh no, duh, I went the wrong way. Yeah, see, indicators, they don't lie, but they can fool you sometimes. Let's go down 1 thou. Try that. Something's going on here. Okay, that's 2. Just loose or what? Oh, 3. Okay, well, that was my problem. This screw over here off camera here was loose, so let me. I'm gonna put my shims back under there and see if I can. Kind of get this back with the world here. Okay, that one's snugged, and that one's snugged. Let's get that out of there. Get that out of there. All right, let's try that again. Okay, so that's pushing the indicator up, so that means it's like this. Okay, so my end, this end has to come down a little bit, which makes sense. Let's see about that. Alright, that's more like it. Alright, let me snug these down pretty good now. I'm going to go back out in the middle here where I can watch the indicator as I tighten this. Okay, that's good. It's not moving. Okay, those are pretty tight now. Okay, that's roughly 1/2 thousandths over that distance there. So I'm going to call that pretty good. Okay, so here, what we're going to do, see if it can work. Yeah, it'll work. What I want to do is I want to put the reed head basically in the center of on the axis of the machine. So what I'm going to do is I'm just going to, what I need is a center line transfer down here. So I'm just going to use a plumb bob here off of a tool that's in the chuck. So I can get this tied here. And there's no like particular reason Let's run that, oops, wrong way, run that out, like that. There's no particular reason that I'm doing this. It's just, if you have a choice, once again, I've said this before, is, if you have a choice to put something on center or not, why not put it on center? Actually, you know what? I need to, dope. I should have lowered that a little more, but if you have a choice, put something on center, measure where it is. A lot of times this pays you back later on when you're doing some other thing. That it's reasonably close to being on center or some other thing. Anyway, it's just I've said it before. It's a workmanlike practice. Okay. So all I want to do is just get a center line in there. That's all I'm doing here. Okay. Nothing fancy. I'm just transferring. Something's magnetic there. I'm just transferring this plumb line. I'll drop it below that a little. Right there. Okay. And all I'm going to do, oops, just put a little mark on that. Okay, that I can work with. So now I got a center line of sorts there. So it's pretty close to the spindle center line, which is what I care about. And then I'll use that to reference the reed head to, and might as well be in the middle of that. All right, so we got the reed head clamped up on center line, and now we're gonna go ahead and transfer punch the mounting holes here. And once again, I'm gonna aim for the kind of the middle of the slot. Make sure I'm straight with the world. Okay. Same thing here. This one's going to be a little harder. I broke my rule of one hit there just because I could feel it and I wasn't hitting it very hard. Well, let's take that off and see what we got there. See if we got a legible mark. Yeah. So the paint is fairly thick there. So what I'm going to do is, just because I'm kind of blind here, I'm going to circle those, and I'm going to go get my get the bigger whacker. All right. Yeah, it looks deep enough. So I'm just using my same little guide block here that I used for the upper one. Get my high-tech depth gauge here. Okay, that one's got to go a little farther. Also, I scraped the paint off here in the area that the reed head's going to sit. That way the adjustment screws are bearing against solid material instead of this kind of soft, squishy paint, which gives it a stable platform. Okay. All right, so those are just pilot holes. I'll go ahead and drill those and I'll tap them. I think it's a M6, I think is what it is. All right, great. Okay, now we'll mount the reed head. I got the set screws in there already. Okay, well, 2 bolts went in, so I'm pretty happy. Okay, so what do we need to do here? I gotta look at the specs on the mounting to see how straight everything has to be. Let's just kind of give it eyeball centric there. Snug those a little bit, and I'll tighten that one up, and then I'll run the indicator around the reed head and see what we get. Alright, so the specs say that it wants a 0.5 millimeter between the scale and the reed head. So this is some brass shim stock here that is a 0.5 millimeter. Well, it's actually doubled. So I'm gonna put that up against the thing, press it up against that, and then snug. Oop, that's pulling that away. I might have to machine a little off of this bracket to get it up closer. Yeah, I'm beyond that. Okay, so I got to take this bracket off here and machine a little off of this face to bring it in a little closer here. Alright, so I machined this bracket until I got the clearance right. I had to take about 2 millimeters off of that, which was kind of surprising. I guess they anticipate this scale being a little farther that way. All I can say is it's better to have material there to work with than to come up short and have to make a bunch of shims or something kooky like that, which would be annoying. It's one thing to whittle away at something and to fit it, but if you got to make if you have to make shims, then it's kind of a hassle. So I'm just putting a little pressure up against that to pin that shim, and then I'll run the indicator along this and see what it looks like for parallelism and all that, and flatness. Okay. The shim, I can move it, but it's snug. There is a tolerance to that, so let's ease up on that a little bit. Yeah, there we go. That's more like it. Okay. All right. Grab the indicator. All right, I'm pretty happy with that. Make sure everything's nice and tight. I still got another direction to check. I need to check this, although I'm hoping that's pretty good because of the shim, and we'll see. Yeah, those are pretty tight. Yeah, it's less than 1 It's less than 1/1000th there. Okay. So let's set that aside for a sec. Oh, actually, let's get that damn sticker on it there. Let me see what the tolerance they have in the instructions for this direction here. Okay, so this is what happens when a machinist gets a hold of something and gets his indicator out, right? You know, you can go bonkers with this stuff, right? And so I looked at the instructions, and they're allowing plus or minus 1 degree in this direction and in this direction. That's pretty generous. So 1 degree over, you know, this is about 2 inches. It's a little more than 2 inches, but 1 degree is 17.5 thousandths over 1 inch, so that's about 35 thousandths that I'm allowed, plus or minus 35 thousandths over that distance in this direction and this direction. So I'm calling this good, guys. We're done with that, and so I'm gonna make sure these are in there good. I'll run those set screws down until they're bearing against there, and then we'll mount the cover.